Hello, dear students. Myself, Dr. Kapil Chaturvedi, Associate Professor in Department of Computer Science and Engineering, Sage Group, Bhopal. Uh, in this lecture, we will discuss on our topic software maintenance and software project measurement, which is the topic of which is our fifth unit of software engineering of fourth semester. And I'm trying to explain the whole fifth unit in this video by just the simple diagrams so that you can easily understand what is actually logics behind of the different topics, and you can easily understand and you can easily write the theory once you understand what is actually logics behind of the topic, so that you can easily write and attempt the questions of RGPB examinations. So let's start. Our first topic is software configuration management. So the meaning of configuration is very familiar for the computer science and engineering students, because we know very well that what is the meaning of configuration. Just think about the configuration of your computer. If I ask to you what is the configuration of a computer, you rapidly reply to me, in my computer 4 GB of RAM, one SSD of 500 GB, one hard disk of 1 TB, and so on. So you tell me, you told me about the configuration of your computer. It means what kind of infrastructure, what kind of tools required for your computer. So what I would like to say, what is configuration? So configuration is the background tools to execute, to run any software. So here the topic is software configuration management. So if we have to manage if you have to manage the configuration of a particular kind of software like hotel management, college management, banking software, or any other kind of application, or any web application, if you have to manage the software configuration, then you must have to focus on these things. You know very well that the steps of software development life cycle, in which we discuss about analysis and design, implementation, testing, and release and maintenance. So in very similar manner, here we have to focus on analysis and design, then we have to focus on implementation, the testing, then release, the maintenance, and planning and specification. In the whole process, in whole process, we have to keep in mind what kind of configuration is required, so that you can easily manage what kind of hardware or related tools configuration you require to implement a software. And after that, our next topic is change management process. So to understand change management, we'll have to keep in mind an example of a project which is already developed, and if you are working on that. Let's suppose an example, you place in a campus in TCS, and TCS appoint you on one of the project which is already implemented, and you are working on the maintenance of that particular project. Then in this case, let's suppose the customer or client contact you to make some changes in the software. So what you will do? So you cannot just can open the coding of that software, and you cannot make the appropriate changes on that time. Once you receive the change request from the client side, you have to make a proper planning for that. To make planning, you have to analyze that, and you have to take the approval from your team leader, either that major changes should I have make or not. Once the team leader approve the changes or approve you to make the changes, then you implement the code, that particular kind of request of the client. And after review and reporting, it means after making the appropriate documentation, you will make the change and release the new version of that software. So this is the cycle says that process will continuously go on in the maintenance phase, when each and every time of many of time client says to make a major change in the application, then you have to make the analysis on that particular request and get the approval from the seniors, uh, and you also have to check that either that change should be feasible or not. Then after the approval you have to make the code, and after review and proper check, and by implement proper documentation, now you can release the next version of that software. And our next topic is version control. The last topic we are discussing about the change management, and I'm saying to you that if we may make a major changes in the software, then we will release the next version of the software, updated version of the software. We make the major changes in the software after approval. So what is version control? So version control, it means once you make the changes in your appropriate copy, once you make the change in the software or assigned module, you must have to update these changes in the server or the centralized system. uh, Before updating the changes in the centralized system, you cannot release the next version. So that process is known as version control. So here that example shows that working copy, here also working copy. So that working copies are the different modules of a particular kind of software. And if they are making major changes, then firstly that they have to update the changes in the centralized repository, as well update the documentation, related documentation and architectures. Then that teams can release the new version. That process is known as version control. Two terms is very important in software engineering from the examination point of view, as well the practical life of software industry. Uh, First one is re-engineering and another one is reverse engineering. So these both of the term are very important from the each and every point of view. Uh, Once we discuss about re-engineering, but before discussing that re-engineering term, you must have to know what is engineering. Whenever you implement a new project, when you are working on a new project from the very beginning level, and you construct a new project, uh, that process is known as engineering. Simply if you are making a program in C, C++ or any other programming language, so that process is engineering. But if you are trying to modify one of existing program, then that process is known as re-engineering. And if you are try to modify that existing program by checking that's output, and you are following the process of bottom to top, you are scanning that code and procedures from bottom to top, by checking the outputs, you are matching what is the input and what is the output, and you are following the reverse way, then that process is known as reverse engineering. So I will discuss reverse engineering in the next slide, but in this slide we have to discuss on re-engineering. So the engineering is a newly construction. Software engineering, re-engineering, it means re-engineering is recognizing and modifying existing software system to make them more uh, maintainable. It means if the software is more customized, then that software will be more maintainable. So in this diagram, to understand that process, you can refer the diagram where we are what we are doing first: inventory analysis, then document reconstruction, then reverse engineering. It means inventory analysis, it means analyzing the things what we have to do. Document reconstruction, it means if we are going to make some new changes to modify our existing program, then we must have to first modify the existing documents, because some of the times we change the existing architectures and diagrams and the UMLs to launch a new version of the software, or making the major changes. Perform the reverse engineering, it means we have to perform re-engineering to optimize, to customize our software. So we have to check the software from bottom to top, what kind of changes, what kind of modification it will require. Then by performing reverse engineering, we'll generate the code. So here we are using the term code reconstruction because code is already available, but we are generating some new code or we modify the code. So here we are using the term code reconstruction. Once we construct the code, we perform the data reconstruction. It means some of the time we have we may be change we may require to change the existing databases, uh, or some of the data to make proper flow of that particular, after make the changes to make proper flow of that software. Here forward engineering is the process where here we are checking the software from bottom to top, and here we are checking the software top to bottom. So in both of the cases, we found some of the lacks in our or drawbacks or the limitations or possibilities to modify our software. We make appropriate changes and launch the software. Again, I am repeating the thing. That process is also a cycle process because that processes will continuously go on in each and every software. If you are taking the example of Flipkart or Amazon, you may realize that softwares will continuously update on each festival. They offer different kind of discounts, change different kind of products. So that will be the and try each time they try to modify and optimize their applications because the number of users are continuously increasing. So they perform re-engineering continuously. And the software reverse engineering, what is reverse engineering, to show to understand that here we have our definition. Software reverse engineering is a process of recovering the design requirement, specifications, and functions of product from an analysis of its code. It builds a program database and generates information from this. So to better understand that, you can refer the diagram where we basically try to optimize the our code, our software to we are trying to uh, make our software more customized, more fast, and more robust. So for that, basically we have to refine the code so that some processes we have to follow raw source code. So we are saying that the existing code is raw source code, and we'll refine that code to perform the clear source code. And then we extract the code, that clear source, the like in that clean code, we will extract and perform that processing interface and database. And finally, here we got the refined code. So this is nothing. You must have to keep in mind the diagram and the term reverse engineering. It means we have to scan the code, scan the software from bottom to top. It means we are scanning in reverse manner. So that process is known as reverse engineering. The next term is SPM, that means software project management. The term is important because the topic will, that the subject will be in your sixth term, uh, named project management. There will be, there you will study the detail of project management. But fundamentally, what is project management? What is software project management? So it will focuses on these four terms: planning, execution, monitoring, and control. So basically is project management is a process of planning, execution, monitoring, and control. First of all, you have to plan how to manage our project, then how to execute that plan, then how to control and monitor the project, and then how to control that all the activities during the software construction. So the management team will basically focuses on these four terms. This terminology, that functioning or that process is known as software project management or SPM. Now, the most important term is feasibility analysis. In the initial classes, we discussed about the feasibility report, where we have to make a detailed document of our project to get approval from the customer side, where we describe what will be the final cost of the approximate cost of the project in detail, what is the technical requirements for us, what kind of front end and back end tool we require, what kind of commercial tool we require, what kind of third party tool we require, what kind of license software we require. So these all description we have to give in technical and given technical feasibility part. Operational feasibility part, in operational feasibility part we will uh, describe in how much modules we will classify our project, and what will be the team size, what will be the effort of the developers, and what kind of infrastructure we require, and many of the things we will discuss in operational feasibility. And in schedule feasibility, will provide our detailed chart, which we will discuss in this PPT, in this video. Next slide, schedule, project schedule. So we have to provide a proper schedule to the customer, on what time we will complete our project, as well on what time we'll complete the design phase, on what time we'll complete the development phase, on what time we will perform the testing. So this chart will be have which we have to provide in advance in one of the report. Customer by reviewing the customer approve that project by studying all these feasibility report, and this is one of the document which will be the final document between client and the company to start the project. Once that process, that documentation will be approved from the client side, company can start the software implementation, software construction, software development, whatever. As we discussed in the last slide about schedule feasibility, it means the project schedule which we have to give in feasibility report. So this is a simple scenario in which we are representing on what time we will complete our requirement specification and analysis. So in as per the diagram, in January's last week and February's first week, some of the days we will complete the requirement specification and analysis, and in February's first, second, and third week, we will complete design phase, and also in February, we will prepare the test cases which we have to perform after implementation. Coding will take the last week from February to March. Last week, it means that we can say that about in 1 month we will complete the coding and perform the unit testing. Then testing will be performed in last week of March and first week of April. So by checking that diagram, you can easily understand on what time we will complete what kind of task. So that chart is project scheduling. Now the managers, when we discuss the project management term, so the team leaders and the project managers continuously monitor that what is the status of your project's implementation in this. They continuously monitor the status of the project by these types of diagrams. So you can see in this diagram, here's some of the chart where task assigned to a particular person, and here we are they are giving the rating, priority of that particular work, and here is the status of that work, either that the work is complete, overdue, in progress, or not started. Here some of the charts we are giving for pending items, budget, and overall task status. So such kind of diagrams or charts will help to monitor the progress of the project. But one thing is very important to discuss here. Instead of controlling this project activity by the engineers, uh, some expert tool are used to do these kind of tasks where that intelligent tools will continuously monitor the project and generate such kind of charts uh, and produce to the manager, and monitor can easily and manager can easily understand what is the status of existing status of and progress of the project. That whole process is known as project tracking. The another term is software quality assurance. Software quality assurance is a part of the testing. We discussed many times in our classes the term quality assurance, quality control, production, and R&D, which is the most important four departments of any of the industry which produce some of the product. In general, we take the example of pharmaceutical company, where production department produce some medicines, and quality control department check the quality of the medicines, either that content of that medicine is proper or not. But in the quality assurance department, the quality assurance executives or the officers check either that the packing or wrapping is okay or not, labeling is okay or not, batch number, barcode, expiry, manufacturing date, so on, and many of the information are not correct or not. If is there any problem, that lot will be reject, and whole lot will be reject. In similar manner, we discuss about the software quality assurance. We have to focus on these 6 points. User experience testing. When we deploy the project on the client side, uh, client will check that project by putting the real data in the software. Functionality testing, where the expert will check the software to check the functionality, either reports are generated properly or not, that performance of that execution of different activities are proper or not. Performance testing, where they check the how much stress that particular web application can take, how much load it can take, how much exceptions, how much errors it can deal. Compatibility test, it means compatibility, it means as you see, as you compatibility, it means you see many of the times, so many of the applications is not properly open in cell phone, so that application is not compatible for mobile or tablet. So here the experts will check that uh, how much compatible that application. Test management will control and monitor the test activities, either that are okay or not. Security testing, it means it will check the security concern as well the risk analysis, data leak concern, data loss concern. So that will focuses on these factors, application is okay or not. So on these 6 factors, so software quality assurance department will work. Uh, the next one is the project planning matrix. Project planning matrix is nothing. As we discussed in the classes many times, matrix means if you're representing something in the form of row and column, in the form of table, then that term, that representation will be known as the matrix in the software engineering language. So when we make the planning on the basis of some factors and on the basis of some features in the form of a table, then that planning will be known as project planning matrix. Here we are taking one example. You can see one example where we are taking some factors, and here we are taking some features, or on the basis of that we are preparing some planning. So that is project planning matrix. The last term is software cost estimation. Once you implement one of the software, you must know what is the cost of that project and how we'll calculate the cost of that project. So the first term is size estimation. Size estimation means line of the code, team size, how much effort it require, how much infrastructure it require. So basically, here you can keep in mind just one thing. If you don't want to remember multi of things, you can keep in mind size estimation. It means we are talking about the number of web pages, number of tables, number of static web pages, number of dynamic web pages, number of line of code. Line of code, it means how much lines of code in your coding source code. Then effort estimation, it means how much people are working in a month on the project. How much duration estimation, it means how much duration you spent during the development of the project. And staffing estimation and scheduling, it means the additional efforts, additional manpower required for the project, and by multiplying that we can easily or to apply these all things on one of the formula, the standard formula, or you can just by multiplying these things you can easily calculate the cost of the product or the software product. So the thing is that to calculate the cost of any of the software, you have to keep in mind about the size, effort, and the duration of spent on that project. So there, here we cover most of the fifth unit's topic uh, by simply diagrams. And I also share the PDF in the group. If you have any question, any query, then you can directly contact to me on call or on email on kapil.rg2@gmail.com. Thank you.